All right. In this video, we'll be looking more on waves parameters, and also solve some questions as far as wave is concerned, and also some exam possible questions. Okay. Now let's take the definition of wave. Okay. Please, all right. Waves are disturbances. Please take note. Waves are disturbances set up by vibrating bodies. Waves are disturbances set up by vibrating body, which result the transmission of energy from one point to another without displacement of the medium. Okay. Now listen, please. When we are saying about wave here, we have actually seen some certain scenario in terms of noise, what again, earthquakes, and then sound. Now all these things display or exhibit wave. Please take note of that. Okay. Now wave can either move. Listen, please. Wave can either move to the direction of the medium, like if I have the medium to be in this direction and the wave is moving towards this direction of the medium. We call this longitudinal wave. Please take note. Longitudinal wave. Please take note. Whenever the wave is moving along, this is just like along the direction of the medium. Whenever the wave is moving along the direction of the medium, we call it upslash longitudinal wave. Please take note. Now, wave can also move perpendicular. Please take note, to the direction of the medium. So if I have this medium like this, and the wave is moving in this direction like this, that is perpendicular along, we call it what? Transverse wave. This is called transverse wave. Okay. Now these are the waves that we have to look into. Okay. Now let's take a look at waves parameters. Please write waves parameters. Now, what are the first wave parameters here? Let's take the first one here. Amplitude. Number one, amplitude. What is amplitude? Amplitude is the maximum displacement. Amplitude is the maximum displacement. Okay. Now, how do we identify amplitude here? If I have a sketch like this, maybe a rough sketch like this. Sorry for this. If I have a rough sketch like this, this is this. Okay, this is just like freehand sketching here. Now the distance from here to here is said to be amplitude, or this to this subclass amplitude. Please take note. And please write, amplitude can be denoted by A or small letter A. Amplitude can be denoted by A or small letter A. Now since it's said to be maximum displacement, that means it will take the unit of what? Displacement. And the unit of amplitude is subclass meter. Please take note. The SI unit of amplitude is subclass meter. Okay. Now let's take the next one here, class. The next one here is said to be period. Please take note. Period can be defined as the time taken. Please write. Period can be defined as the time taken to cover one circle. Please take note. Period can be defined as the time taken to cover one circle. It can be denoted by T. Please take note. It can be denoted by T, and the SI unit subclass seconds. Okay. Now please write. Mathematically, please write. Mathematically, period can be expressed as T is equal to 1 over F. This is the mathematical representation of period between frequency. Please take note. Now, we can also represent period in terms of angular frequency. What is that? This is said to be T is equal to class 2 pi over what? Omega. Please take note. 2 pi over what? Omega. This is in terms of what? Angular frequency. This is the formula for period when relating to what? Frequency. This is the formula for period when relating with what is class? Angular frequency. This omega is called angular frequency. I'm going to tell you more about this omega here, when we can use it as angular frequency, or when we can also use it as what? Angular velocity. Please take note. Okay. Now let's take the next one here. Frequency. Okay. Number 3, frequency. Okay. frequency. Please write. Frequency can be defined as the number of time taken to cover one circle. Frequency can be defined as the number of time taken to cover one circle. Okay, it can be represented by f, and the unit is said to be hertz or per seconds. Please take note. The unit is said to be hertz or per seconds. Okay. Now let's take the next one here. Next one here. Okay. Okay. Now the mathematical the mathematical representation of f is said to be between periods. Said to be f is equal to 1 over t. Please take note. Sorry. Okay, now let's write the mathematical representation of frequency here. Now, frequency can be represented mathematically as f is equal to 1 over t. Please take note. Or is the same as from this formula here. Is the same as f is equal to omega over what? 2 pi. Please take note from this formula here that omega is equal to 2 pi f. You can make this f here the subject. That will be this guy here. Please take note. Okay. Now this is the formula of frequency. Now when relating to period is this. When relating to angular frequency is this here. Okay. Now the next one here 4 is said to be wavelength. Wavelength, we use lambda to represent this. Okay, wavelength, we use lambda to represent wavelength. Okay, now let's define what wavelength is. Please write. Wavelength can be defined as the distance covered by wave. Wavelength can be defined as the distance covered by wave. Please take note. Wavelength can be defined as the distance covered by wave. It is denoted by lambda. This is called lambda. Please take note. It is denoted by lambda. Now, the unit of lambda is said to be in what? This class, meter. Please take note. The unit of lambda is said to be what? Meter. Okay. Now, the next one here is said to be velocity. Please take note. The next one here is said to be velocity. Let's define this in terms of wave and also in terms of the one we know here in normal physics. Okay. Now, in terms of normal physics, we say that not related to wave. We say that displacement is the rate of distance, or displacement. Is the rate of distance or displacement. That velocity is the rate of distance or what? Displacement. Please take note. Now, most times we use displacement, we also use what? Distance, because there's no difference between velocity and what? Speed, except when you want to classify that in terms of what? Scalar or what? Vector. Please take note of this. Okay. Now, is the rate of displacement. Now, it can be written as v is equal to x over what? T. Or velocity in terms of wave can also be expressed as wavelength per unit period. Please take note. Wavelength per unit period. That means v is equal to lambda over what? T. Please take note. Now look up here, please. Let's try to understand the question here, the formula here. Now, whenever you are given normal distance and you are given normal time, you are going to use this formula here. But whenever you are using wavelength, you are going to use it with what class? Period. Please take note. Okay. Let's solve question 1 here. Example 1, please. Example 1. Okay. Let's solve this question here. That is this question 1 in terms of wave. Is a wave pulse on a string. Okay. A wave pulse on a string moves a distance of 8 meters in 0.04 second. Determine A, the velocity, B, the frequency of a periodic wave on a string if its wavelength is 0.5 meter. Now, we are going to apply most of our wave parameters here. Of course, we are going to write down the given parameters. If you want to know how to solve this very clearly here, know how to know the parameters involved and what you are asked to solve. If there's any condition, you apply the condition. Okay. Now let's check our given parameters here. Okay, given. What are the stuff given to us here, please? The distance. Remember, it's not wavelength, it's distance. So the distance here given to us is what? This class 8 meters. Okay, the time there given to us here, subclass 0.04 seconds. Okay, now after they say determine the velocity here, remember that we have two formulas in expressing velocity here in terms of wave. We have in terms of normal in a normal distance, in a normal velocity formula, that is displacement over time. We also have relating to wavelength, that is v equal to x over t, or v equal to lambda over what? Period. Lambda always go with period, please take note. While normal distance will go to what class? Normal time. So if you look into these parameters here, what is given to us here is normal distance and what? Normal time. I'm going to take this formula, not this formula here. So using this formula here, using v equal to s over t, let's replace the given parameters here. This will equal to 8 over what? 0.04. Okay. Now punch your calculator. 8 divided by 0.04 plus, what is this thing here? 8 divided by 0.04. So here, 8 divided by 0.04 will give us 200 in what? Meter per second, of course. Now, this is the first question here. The next question here, they said the frequency of a periodic wave on a string if its wavelength is 0.5 meters. Okay. Now, this guy here, they gave us the condition that lambda is 0.5 meters. Okay. Now, how do we solve this here? Now, since velocity is already given to us here, and lambda is given to us, we are asked to find what? Please class, we are asked to find what? Frequency. But remember that there is a particular formula that relates velocity, wavelength, and what? Frequency. What is that formula here? We say that from this, that from V equal to lambda over T, this is the same thing as all right. Let's solve this question here. This is actually an exam possible question we can see as far as wave parameters questions are said to be concerned. Okay. A radio station broadcasts at a frequency of 200 kilohertz. Okay, I will interpret this later. If the speed of the wave is 3 times 10⁸ meters per second, that's speed of light, what is the wavelength? All right. Now listen to me. First of all, you list out the given parameters given to you. This is how we solve physics question. Please listen. You list out the parameters given to you. Now, if there is any condition at that point, you obey that condition. Okay? Let's say if the speed, that means if this is the condition here, the speed, the given parameters are said to be, these are the given parameters here. That is the frequency f, the frequency f is given to us as 200 kilohertz. Please take note. Now, after they say that, the velocity or speed, the v, is given to us as 3 times 10 to the power of 8 meter per second. Now, what are we asked to calculate? They say, what is the wavelength? What is the wavelength? So they are looking for what is class lambda. That is the wavelength here. But I told you guys that there are some formula relating to velocity. Now, the one that relates with displacement and the one that relates with what is class wavelength. Now, I'm not going to use the formula for velocity that relates with what? Displacement here, because what? We are looking for what is class lambda. Okay. Now, let's write our equation here. Our V will be equal to class from what we know, F what is class lambda, because this particular equation is focusing on velocity, frequency, and what? Lambda. But if you look into this guy here, that is frequency here, this is said to be kilometers, hence, kilo is a prefix. We have prefixes in mathematics, okay? We have prefixes in mathematics. What are they? We have kilo. Kilo is said to be times 10 to the power of what? 3. Please take note. We have micro. Please take note. Micro, that is this, is said to be times 10 to the power of what? Minus 6. We have nano. Please take note. Most of the prefixes that end with O are mostly, apart from kilo, most of them that end with O are mostly negative. Please take note. This is said to be times 10 to the power of what? Minus 9. Please take note. We have pico, okay, in case they give you pico. We have pico. Pico is said to be times 10 to the power of what? Minus 12. Please take note. We have giga. Giga, anyone that ends with A, please take note. Most of them that ends with A are mostly what is class? Positive. We have mega, we have giga, okay, please take note. Mega, mega M is said to be times 10 to the power of what? 6. Please take note. We have giga, this G, like this, to be times 10 to the power of what? 9, okay? Now, these are the prefixes you need to know for now. Now, when they say kilo, it means that it has a numerical value attached to it. Just like if I say this to be maybe 2s, like this, and they said s is equal to 2. What does it mean? It means that anywhere I see s, you replace what class 2. So the same thing here. Anywhere I hear about kilo, you replace what is class times 10 to the power of what? 3. Please take note. So that means this is going to be V is given to us as 3 times 10 to the power of 8 is equal to, okay, this is 200 times, that is for this kilo here, 10 to the power of what? 3. Please take note, times what? Lambda. So let's make lambda the subject. We divide both sides by what is attached to lambda. That means our lambda here will be equal to class 3 times 10 to the power of 8 divide by what? 200 times what? 10 to the power of what? 3. Okay. Now let's solve this. 3 divided by 200. Let's get the result, please. All right. Let's point to our calculator here. This is the simplest way to calculate something like this. First of all, you divide. It is number to number. You divide number to number. It is in terms of times. You times number to number. Please take note. And you can now simplify the terms using your indices. Let's go. 3 divided by 200 is what? 0.015 times. Let's simplify the powers here. This is 10, this is 10. From the law of indices here, you take only one. That is 10. Please take note. Oh, they already did that one. Okay, now this is 10, this is 10. You take only one. That is 10 raised to the power of 8. Now, whenever you are taking anything from denominator, any power, from denominator to numerator, is going to change its sign. If it is plus, it will change to minus. If it is minus, it will change to up slash plus. This will be minus 3. So let's go here. This will equal to 0.015 times 10 raised to the power of 8 minus 3. What is that up slash 5? Please take note. I have this to be 5. So let's solve this standard form here. Let's take out the decimal point here. Take out the decimal point. How many? 1, 2, 3. That means I'm going to take out 3 here. I'll be left to drop the raised to the power of 2. Please take note. So 15 times 10 raised to the power of 2 is going to give us the same as 500 in what, please class? Meters. Okay, this is my answer here. So, but in the option, we are asked to represent this in terms of kilo. How do we do that? We divide by what? 1000. So divide this result here by 1000. I'm going to have my answer here. Please take notes. When you divide by 1000, that means lambda will be equal to 1500 divide by 1000, which is going to give us this will cancel this. That is 1.5 represented in what? Kilometer. Okay, please take note. All right, in our next video we are going to treat progressive wave and also solve some exam possible question, and also tell you guys how we can easily solve progressive wave. If I have something like this, y is equal to something like this. Now, this is what we are going to solve in our next video. If I have something like this, y s comma t is equal to a sine into omega t plus or minus 5 like this, and you are asked to find angular frequency, which I told you guys that when do you call this angular frequency, and when do you call this angular velocity? Okay, we are going to know it from here. And how can we interpret this when it is said to be plus? How can we interpret this when it is to be minus? Now, what is the wave movement? If it is plus, is it moving from maybe right to left, or is moving from left to right? If it is minus, is it moving from left to right or right to left? Okay, now we are going to know what is said to be. Okay, all you have to do here is to subscribe to the channel and get all our packages, that is all our videos, and also you can easily pass anything about physics or mathematics. Thank you so much.